All right, today is our third day of looking at systems of equations, which is again a set of two equations, and we're trying to find the point at which they intersect or cross if we're looking at a graph. So today we're going to solve by what's called a method of elimination. So for this one, you want the equations to actually be written in standard form, which is ax plus by equals c. So I'm reading from over here. So you can always kind of refer back to these notes and see if you need. So for this question, I'm going to do this one over here along with you. So they are already in standard form. So it's ax plus by equals c. So essentially a number in x, a number in y, and then c is just a constant or regular number. So they're in that form, so we're good to go on step 1. Step 2 is if either of the like terms have the same coefficient, we can add or subtract them to make them cancel out. So I'm trying to see if I can cancel either of these out. So my coefficients currently are, sorry, trying to zoom that in. I have 3 for the x on both, and then I have a -1 for y and a +1 for y. So the easiest here would be to cancel the y's because they're already opposites, okay? So I'm just going to think, okay, if I add this whole line, so 3x plus 3x gives us 6x, -1 plus 1 gives us 0, so the y's cancel, and then 6 plus 0 equals 6. All right. This says if they do, step 3, if they do not have the same coefficient, we can multiply one equation to make it have an opposite that will cancel. So this one I didn't need to do that, so we might get to one of those in a second. So I don't need to do that on this one. Step 4, so we're going to finish solving for this variable here. So I'm going to divide 6x by 6, and that gives me x equals 1. So step 4 says once you have solved for one variable, so I solved for x, plug it back into either of the original equations to solve for the remaining variable. And you always write your answer as an ordered pair x, y. I like to write that as I'm going, that way I don't forget which I solved for. So if I had x equals 1, that goes first because it's x and then y. All right, now I'm going to plug x in to get y. So I'm going to erase this so you can see. So you can plug into either the top or the bottom. Try to pick which one would be easiest to solve. So like in my case, I usually plug into the positive. So I'm going to plug into the bottom. So 3 plug in means I'm replacing x with its number now. So x equals 1, so I put in parentheses, plus y, we still don't know y, we're trying to find that, equals 0. All right, this simplifies 3 times 1 is 3, plus y equals 0, and then I would subtract 3 from 0 to give me y equals -3. And final answer would be 1, -3, and that is a one solution system of equations. Okay. All right, so on number 1 here, you want to think, all right, which would be, the x or the y would be easier to eliminate. So x currently has a coefficient of 1 on both of them, and you want to try to find opposites if you can. So in this case, 1 and 1 are the same. -2y and +2y, though, are opposites. So I know they're going to cancel out if I add them. So I'm adding all the way down everything. So 1x plus 1x gives us 2x. -2y plus 2y cancels. And then -7 plus 5 gives us -2. Finish solving for x by dividing by 2. X equals -1. I'm going to write that in my ordered pair. And now you want to take x and plug back into one of these equations. So again, I'd probably plug into the bottom just because it's positive. So now, so if x plus 2y equals 5. So if x is 1, that should now say 1 plus 2y equals 5. Subtract 1, 2y equals 4. Divide by 2, y equals 2. And finally write it in the ordered pair, and that is one solution. Okay, so number 2 is a little bit different. Currently, so 9 and 3 and 4 and negative 10, neither of those are currently opposites. So that means I'm going to have to do that multiply option that we talked about, I think it was step 4 up there. So I want to think, okay, does 4 go into 10? No, so I don't want to multiply the 4. That's not the one I want to try to change. 3 does go into 9, so I want to try to make this 3x be the opposite of 9x. So to do that, I can multiply this entire thing. So to get opposite of 9 would be negative 9. So negative 3 times 3 would be negative 9. So I'm going to rewrite all that here. So I'm basically distributing this to all of it. So negative 3 times 3x is negative 9x. Negative 3 times negative 10y is 30y. And then negative 3 times negative 2, don't forget that far side, is 6. Okay, this top original equation, I'm just going to rewrite that one so it's right underneath here. So these are now what I'm working with. Now we do have a set of opposites. So negative 9 and 9, so that means I can add this whole bottom row. So negative 9 plus 9 cancels out. 30y plus 4y is 34y. 6 plus 11 is 17. Divide by 34. Okay, please be careful here because 17 divided by 34 is not the same as 34 divided by 17. So this is, sorry, saying what I'm writing. 17 divided by 34 comes out to 0.5 or 1/2. All right, it seems like usually we end up solving for x first, but in this case it was y. So just make sure in your ordered pair that the y goes second. All right, so now I'm ready to take this and plug it in. I would probably do your first equation. Here, so you're actually going to plug in for the y, so think right there. So 9x plus 4 times, now I can use 0.5 or 1/2. I think most people usually prefer the decimal, equals 11. Okay, 9x, 4 times 0.5 is 2. Subtract 2 from 11. Divide by 9. X equals 1. And so my final answer is 1, 0.5, which is one solution. Okay, make sure you complete the homework for today's lesson, 2.6, and message me if you have any questions. Have a great day.